let's study the admixtures. Chemical admixtures are materials in the form of powder or liquids that are added to the concrete to give it certain characteristics, not obtainable with plain concrete mixes. Accelerators speed up the hydration of the concrete. Typical materials used are calcium chlorides, calcium nitrates, and sodium nitrates. However, use of chlorides may cause corrosion in steel reinforcing, so that nitrates may be preferred. Accelerating admixtures are especially useful for modifying the properties of concrete in cold weather. Retarders, in the opposite, slow the hydration of concrete and are used in large or difficult pours, where partial setting before the pour is complete is undesirable. Typical sugar, sucrose, sodium glucose, citric acid, and tartaric acid are used. Air entraining agents add and entrain tiny air bubbles in the concrete, which reduces damage during freeze-thaw cycles, increasing durability. However, entrained air entails a trade-off with strength, as each 1% of air may decrease the compressive strength by 5%. If too much air becomes trapped in concrete, defoamers can be used to encourage the air bubble to agglomerate, rise to the surface, and then disperse. Plasticizers increase the workability of plastic or fresh concrete, allowing it to be placed more easily. A typical plasticizer is lingosulfonate. Plasticizers can be used to reduce the water content of a concrete while maintaining workability. Pigments can be used to change the color of concrete. Corrosion inhibitors are used to minimize the corrosion of steel and steel bars in concrete. Waterproofing admixtures can be used depending on the function of the concrete and nature of its exposure. As a naturally porous material, though and one that is prone to cracking, concrete is vulnerable to water infiltrations. Waterproofing admixtures reduce concrete's permeability. One of the additive categories for waterproofing consists of hydrophobic or water-repellent chemicals derived from soaps or fatty acids, vegetable oils, and petroleum. These materials form a water-repellent layer along the pores in the concrete, but the pores themselves remain open. The other category is finely divided solids, either inert or chemically active fillers such as talc, siliceous powders, hydrocarbon resins, and coal tar pitches. These materials densify the concrete and physically limit the passage of water through the pores. Let's say that we are going to make a concrete structure construction in a very cold climate during winter. In this situation, which admixtures should we use? First of all, we must decide that if we want to pour the concrete as fast as we can, or otherwise the reaction between cement and water can be destroyed due to the cold weather. We need to accelerate the setting by choosing calcium nitrate or sodium nitrate. Okay, we put the calcium nitrate in the concrete and fasten the setting, but it's too much. Let's imagine that it's too much, and it began to set before we put the concrete into the molds. And it can be dangerous for the construction. What can we do? We can use plasticizers like lingosulfonate that can allow us to place the concrete more easily. It's a porous material. Concrete is a porous material. It can take water, absorb water, and due to cold climate, if the water inside the concrete freezes, it will deform the concrete. It can be dangerous. We have to choose one of the waterproofing admixtures. We must decide that if we want the pores open, or if we can fill the pores up. In my opinion, if we don't want to water to go into the pores and expand during the freeze thaw cycles, we need to decide, we need to choose the other category, the second category of water proofing admixtures. It's the finely divided solids, such as hydrocarbon resins. This product limits the passage of water through the pores. In this situation, we should write on the project that we are choosing a reinforced concrete with calcium nitrate as accelerator, lingosulfonate as plasticizer, and hydrocarbon resins as waterproofing admixture.